Hello, in today's video we're going to be making a homemade alkaline battery with the alkaline part of the battery being made directly from nature. For the parts derived from society, we'll be using recycled parts like the little aluminum cat food can lids, steel or iron from these can lids, little plastic containers for bubble gum, and of course, a few parts from the hardware store like wire and bolts. Now, for the electrolyte, we'll be getting that directly from nature using limestone and wood ash. Trees are, of course, alive, and therefore they contain DNA. DNA is comprised of carbon, hydrogen, nitrogen, phosphorus, and oxygen. So we know the plants and wood on the ground that we find that we can burn are made, we're going to have those ingredients in them. But it's only about 1% of the total, much like a set of plans in a building. The plans tell the builders what to build, but they're not the entirety of the building. So DNA is only about 1%. What else do trees and plants have in them? Well, wood is going to contain a lot of calcium, potassium, and magnesium. Magnesium is mainly in the leaves, which is essential for photosynthesis. The ash from a typical wood fire is going to contain calcium oxide and calcium carbonate, but calcium compounds are not particularly soluble in water. What is soluble in water is potassium carbonate, and that's what we derive from wood ash, potassium carbonate. The wood ash and water is stirred around. Then, over time, it is allowed to settle, and the liquid can be decanted off. This water is going to be containing a lot of potassium carbonate. Then the water needs to be evaporated to concentrate the water-soluble potassium carbonate out of solution. This can be done over time using simple evaporation methods. In my case, I used a small pump and a solar panel to circulate the water so that it would evaporate in the summer. Once the solution is more concentrated, heat can be applied. And finally, after some time, we have dry potassium carbonate. These sedimentary rocks are found directly in the soil where I live. They contain calcium carbonate, no doubt, but limestone, which I find on roadbeds, is going to contain almost all calcium carbonate. Now, what we're going to do with the limestone is convert that calcium carbonate into calcium hydroxide. In order to do that, it takes a lot of effort. First, we have to heat this to a very high temperature for a long period of time. That breaks it down from calcium carbonate to calcium oxide, releasing CO2 at the same time. Once we have calcium oxide, we can then take it and quench it in water. The calcium oxide is converted into calcium hydroxide paste.
Pretty cool. Oh, it's getting hot, I can feel it.
Over time, I boiled down this paste until it was thick enough that I could put it on a scale and measure it easily. It would contain some water, so the ratios were experimental. When calcium hydroxide is combined with water and potassium carbonate, a chemical reaction occurs. The potassium carbonate turns into potassium hydroxide, and that's what we're after. It's a strong alkaline substance that's corrosive, but it can be used in a wide variety of materials: food, medicine, concrete, soap, and many other things. It is one of the first and most important chemicals that humans have discovered. During this reaction, limestone is again produced. The limestone that was converted into calcium hydroxide with heat turns back into limestone again, and that can be filtered out and put back to the earth. We've collected our steel can lids, tin can lids, and the aluminum can lids from cat food. But now we have to get all the plastic and paint off of these so that they'll conduct the electricity and go through the chemical process. Originally, I was going to put it in this PVC tube here, make a circular shaped battery, but we're going to try a different way. So, a little something about aluminum. It comes from a clay called bauxite. And in order to get the aluminum, you have to use a lot of electricity and a lot of hydroxide chemicals to refine it from the earth. The refining of raw earth ingredients to a more refined state, we would consider that alchemy. So to do what we're doing here, it's actually kind of reverse alchemy, if you want to think of it that way. Now that we have all the iron can lids cut to shape, we can burn off the paint and epoxy coating that's on this, which, by the way, probably not good to have in your food. All the epoxies, the bisphenol A, all the genital shrinking, hormone altering substances. But anyway, kind of a musical sound. We gotta use the wire brush to clean off the scale from the fire on the steel or iron. Use an 1.5 inch long number 8 machine screw and a 5/32 drill bit. Arrange the metal in a way such that it doesn't grab the metal and spin it, turning it into a blender which will chop your hands to an absolute pulp. The plastic containers are a little more forgiving. Just use a backer block when you drill it. These dimensions are about 2 1/16 by 1 1/4, I think. And you stagger the whole spacing. So I soldered up these little brass connectors, thumbtacks, to make dummy battery terminal connectors that would match a AA size battery. But yeah, there's nothing in there, it's just wood. Okay, y'all, here's the battery. So we have 12 of the cells. Each cell has 3 steel anodes and 10 aluminum cathodes. I have to make sure that they're not touching, but they need to be very close. And I'm gonna fill it with the electrolyte here, and we'll go from there. Had to get all of them because of the voltage drop.
Brought Metallica together with the addition of Kirk Hammett and Cliff Burton. In 1983, they released their debut album, them, kill 'em all.
Okay, this is test number 2. I did a different electrolyte blend without the sodium, so completely from nature. Maybe this time we'll have more luck with it. Hey, it works. You can hear the battery drain down. When you have a motorized device, it really draws some power from it. Let's try maybe FM radio. Oh, there you go. Let's try AM. That's pretty cool. I mean, it works. It's not working great, but it's working. Dallas, Texas. I heard him say it. Let's go back to Metallica. This time I spiked it with a little hydrogen peroxide. Maybe that'll help give it a little bit oxygen. Maybe run a little bit better. Hell yeah. Yeah, the hydrogen peroxide, I think, boosts the amperage. She's getting hot. Let's check the amperage on this bad boy. It's spiked up to about 182 milliamps. Let's check the voltage. Yeah, that's a 6 volts. This is a 3 volt radio, but when you hook it up, the amperage drops. So anyway, maybe we'll hook it back up and see what the voltage drop is. Yeah, there you go. Almost 3 volts. Notice the little battery indicator light is like pulsing as this thing continues to sizzle uncontrollably, releasing explosive hydrogen gas. Yeah, the peroxide gets it going. Yes. So, what did we learn from this experiment? Well, we learned that we can't compete with the economy of scale. A battery like this is very expensive in terms of labor to produce, but the materials are cheap. And it would make sense that iron oxide and aluminum could be used to make a battery. After all, that's how you make thermite, iron oxide and aluminum powder, a very explosive and powerful substance as far as heat generation. So there's a tremendous amount of energy there. If that energy can be harnessed, it can be turned into electricity. Potassium hydroxide makes the perfect electrolyte for this process. Now, with all that said, we learned a few other things. We learned oxygen adds to the equation. So if you could have a battery designed either with pumps or perhaps something simple like a fabric mesh that could allow air to touch certain portions of the battery, whether the anode or the cathode, during the reaction, that oxygen will be the last component of this reaction. So you need iron, you need oxygen, you need aluminum, and the potassium hydroxide. Those ingredients combined in the right way can make an effective battery.